Hello, let's continue our Sudoku adventure with Unremarkable by rockratzero. So this begins our theme week for August, and our theme is Escape the Grid. So these are going to be any puzzles where you are going to have to fill something outside the grid. It could be like here where we have circles that interact with the inside of the grid and also need to be filled and count as clues. It could be even lines just leaving the grid and coming back in. Interesting stuff like that. So should be an interesting week. Cool. So let's go over the rules to this puzzle. We do have normal 6x6 Sudoku rules. So in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We do also have X sums. So these 3 circled cells that are outside the grid give the sum of the first n digits in that row or column, starting from the clue, where n is the digit that is right next to the clue. So if this was, say, a 5, then that tells us that starting from here, let's say this was a 2, these 2 cells sum to 5. So this is one way to fulfill this. So this would be a 5, so our sum is 5. This 2 tells us use 2 cells, including itself, and we do 2 plus 3, and that's 5. Another option would be, say, if we did 6, and then we did 3, 1, 2. This says the sum is 6. This 3 says use 3 cells starting from there, and 3 plus 1 plus 2 is 6. From here, you would use this cell and work your way up. From here, you'd use this cell and work your way right. Hopefully that makes sense. All right, all of the circles in the grid, including the ones that are for X sums, are counting circles. So a digit in a circle indicates exactly how many circles contain that digit. So if this was a 5, then that tells us that 5 of our circles contain a 5. Exactly 5 of our circles. So we could do, say, 5 here, 5 here, 5 here. I might struggle doing this right. Anyway, that's 4, but there would be a 5th one. Anyway, it's not super important, but if a digit appears in a circle, then it appears exactly that number of times in a circle, equal to that digit. And before I forget, we also cannot repeat digits outside the grid. So if this is a 5, then we cannot repeat the 5 in these 2 cells. So this would not be allowed. All right, and that's definitely something that hopefully people notice when they read the rules. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okie dokie. With counting circles, usually the place to start is to count them. Weird, right? So we've got 3 outside the grid. That's 3, 4, 5, 6, 7, 8, 9. So there's 9 circles in total. Now, why did we count them? Well, if you think about it, whatever digit we put somewhere, that uses up exactly that number of circles. And so a 3 uses up 3 circles. A 2 uses up 2 circles. So if you think about it, that means that the unique set of digits in the circles will add to the total number of circles. The 3 used up 3, the 2 used up 2, right? Now that uses up 5 in total, and now we have 4 left, right? And then a 4 would finish it. And so, so the 2, 3, 4, that's 9. So we don't know exactly how many numbers there are, but we do know that they end up adding to 9. The other thing we know is that we can't repeat any digits outside the grid. Therefore, we need at least 3 unique digits to fill into these circles to add to 9. Now, I can tell you that 4 unique digits cannot add to 9. And important to note is that you cannot put a 0 in an X sum. There would be no way to fulfill that clue. You can't sum to 0 with at least 1 cell. So this would be 1 already. So anyway, you cannot use 4 digits to sum to 9 because 1, 2, 3, 4 sums to 10. So therefore, whatever these 3 digits are the 3 digits, and they sum to 9. So there are 3 ways to sum to 9 in 3 digits. There is 1, 2, 6, 1, 3, 5, and 2, 3, 4. So interesting. Do we know anything else? Like there's not. So we are okay. So there is one thing about summing to 9 that's a nice property to think about. I don't know if it's going to be helpful in this one, but we should think about it, which is that you get 2 digits between. So let's just use these 3 as scratch. You get 2 digits that are from 1, 2, 3, and 1 digit that's from 4, 5, 6. Obviously, if you had 3 digits from 1, 2, 3, you would sum to 6, not 9. If you have 2 digits from 4, 5, 6, the minimum that you add to is 10. 1 plus 4 plus 5 is 10. So you need 2 from 1, 2, 3, and 1 from 4, 5, 6 in order to get to 9. So for example, we could do 1, 2, 6, right? 1, 2, 6. We could do 1, 3, 4, or we could do 1, 3, 5, or we could do 2, 3, 4, right? And so you can see that they always have 2 lows and 1 high. So that means that we need a digit that's at least 4 in these circles, which means we need at least 4 circles to do it. Now, what's interesting is we do have a 4 placed, which tells us that these two can't be 4. So let's gray out the ones that can't be 4, first of all. And then we now have 1, 2, 3, 4 boxes available. And it looks like all of these could be a 4. Oh, hold on. No, this one can't be 4 either. Sorry. So we have 1, 2, 3 available that can all be 4. And then we can put a 4 outside the grid. So 4 is definitely possible, unfortunately. I say unfortunately because I thought this 4 would perhaps tell us that. Now let's see, maybe 5 is not possible. So we could put a 5 here. That seems, okay, let's count the columns. We get 1, 2, 3, 4 columns. We get 1, 2, 3, 4, 5 boxes. This is going to be good to know anyway. 1, 2, 3, 4, 5. So we have 4 columns, 5 boxes, and 5 rows. So the columns are what limit us. So we can do a 5 in each column. Oh, okay. So like this is how we would do a 5 in each column. And then we could put a 5 outside the grid. So we can have a 4 or a 5, but we cannot have a 6. Because, this row is completely empty. And this column's empty and this column's empty. So we cannot do 5 6s inside and a 6 outside. That restricts us from not being 1, 2, 6. So we're either 1, 3, 5 or 2, 3, 4, meaning there's definitely a 3 in one of these. Hopefully, this is the thing to think about. I don't think the X sums help us immediately. But it does mean that we can immediately in all of the circles let's fill 1 through 6, but we know we can't have a 6 in them, and these can't be 4s. I don't know if this is helpful yet. So we're either 1, 3, 5 or 2, 3, 4. 1, 3, 5 or 2, 3, 4. 1 is a very special X-sum number. It's just fulfilled by putting a 1 next to it. Otherwise, you can't put a 1 next to. Like if this was anything other than 1, like a 2, putting a 1 here tells us that 1 cell adds to 2, but there's already a 1 sitting there. So it doesn't work. So 1 through 5 tells us that none of these digits are bigger than 2. Because as soon as I put a 3 here, I need to use 3 digits to add to the sum, and that's a minimum 6, and they can't be 6 anymore. So these 3 cells are from 1, 2. So that's a 1, 2 pair here, meaning that's not a 1 or 2. And so that means that, this is either a 1 or a 3. Because either this is 1 or 2. If it's 1, then this is a 1. If it's 2, then it adds to 3. So 1 or 3 only here. And now here, this is minimum 3. So this can't add to 3 because we'd have to be 2, 1, and we can't do that. And then, we could be a 1 here, and this would be a 1. We know we always need a 3, so knowing that this ends up 3 sometimes doesn't really help us. 3, 4, 5. What else can I do here? How about this one over here? So, I think anything's possible here. We aren't repeating digits outside the grid. I need to remember that. So, what are we doing? This isn't 1, 2, or 4. This is 3, 5, 6. I feel like I'm missing like the opening to this. Like I maybe haven't even seen the point of the puzzle yet. Four is down here. Okay, so do we think about this in any way? Let's think about the 4 or 5 that must appear. Right, one of these is 4 or 5. Right, so they can't be the 1, 2, or 3. Wait, no, one of them is 4 or 5. The other is a 1, 2, 3. What am I talking about? So I feel like this one's going to have a harder time being 4 or 5, although it's not that hard. So if this was a 4, then our only option... Oh, wait, we can't do 4, can we? That might be the key deduction there. We can't do 4, because how would we fulfill 4? We're certainly not doing 2 plus 2. And 1 plus 3 would require this to be a 1, which means it doesn't actually include the 3. We can't put the 3 here, or we'd use 3 cells. So 4 is actually not going to happen. Which means that we are using the 5, which means we're 1, 3, 5, or 1, 2, 5. So this is a 1, so that's a 1, that's a 2. No 1's here. Oh, and no 2's here, because it's 1, 3, 5. So that's our 5, and that's our 3. Okay. So 2 plus 3 is 5. Oh, and I can just say, okay, these are all from 1, 3, 5. So that's our 5. That's 6. That's not 5, that's not 1. Oh, and we can't put more 1s because we already have one circle that's a 1. So that ends up a 3. That ends up a 5. That ends up a 3, and that ends up a 5. And I think we already have 3 3s, so this has to be a 5. And that works. Okay, so all the circles are filled. So now this is a 4. So down here we need 1, 2, 4. Up here we need 3, 5, 6. So that's our 6. That's 3 and 5. 3 in the corner, celebrating. These are... Yeah, we need a 3 and we need a 2. These 3 digits, we need a 1. Oh, we do need a 5, which ends up right there. So these are 1, 6. 1, 4, 6. It's not a 6. 1, 2, 4. Oh, I do have some X sums to do. 2, 3 worked out. This 3 needs to be 2, 1. That should help. That's our 4. That's a 4. That's 1. That's 6 and 4. That's 1. That's 2 and 1. Down here, we need a 2, 6. So that's 6 and 2. Down here, I need a 3 and a 6. Last digits, we need a 1 in here, which goes here. We need the 6. We need the 2 and... Oh, no. The 2 and the 4. Okay. Cool. Nice puzzle, Rockrat. Nice start to our Escape the Grid. Definitely took some thinking. I think the big deduction was that 4 was not possible as an X sum. Yeah, which I didn't really think about. But yeah, there's just no way to do a 4 X sum. I don't know if I'd realized that before. Yeah, you can't do 1 within... You can't do 1 cell. You can't do 2 cells, because that would include a 2, and 3 cells is minimum 6. Interesting. For some reason, I just don't recall ever noticing that you can't have a 4x sum. All right. Well, cool. I hope you enjoyed this. And if you did, then why not leave a like, subscribe, and a kind comment below.